Okay, so let's talk about the QSC D16MIO. You look at this thing, and it's just a standard 1U black box.
Right. Nothing special at first glance.
But then you see the price tag, we're talking north of $4,400, and you realize, okay, this isn't some basic breakout box.
Yeah, that definitely makes you look twice. You're paying for density and, deep integration.
Exactly. And that's really our mission for this deep dive, to figure out what makes this networked audio interface such a powerhouse.
Well, it's the bridge. It's the thing that gets your legacy analog gear
Yeah.
talking to a modern QSYS network.
And it does it with some serious density. I mean, the form factor is the first thing that jumps out.
It is. We are looking at 16 inputs and 16 outputs.
32 channels of I/O crammed into a single rack unit. That's impressive.
It is. And it's not just about fitting the ports on the back, it's the quality of the signal path. They're packing 16 studio-grade preamps in there.
That's what I wanted to ask about. I saw the gain specs up to 51 dBB, which is good, but it was the control that caught my eye. Digitally controlled in 3 dB steps.
Oh, that's huge. For a system integrator, that stepping is a lifesaver.
How so?
It's all about recalibability. In a fixed install, like a convention center, you need the system to reset to the exact same state every time. You want a hard digital 3 dB step that's identical every time you load that preset.
Ah, okay, so it's about consistency over having like a smooth, continuous knob.
Precisely. And speaking of the quality of those preamps, that EIN number,
Right, 125 dB, that's a very low noise floor.
it is, for the listener putting this in a quiet boardroom or a theater, that's the difference between a pristine signal
Yeah.
and, fighting that low-level hiss.
So you've got this incredibly clean analog capture, but the real magic is how it gets onto the network.
And that's where Dante with AES67 interoperability comes in.
That interoperability part is key, right?
Right.
It means it can play nice with other brands.
For sure. But the physical ports are what I found really interesting. You've got 4 of them.
Yeah, 2 standard gigabit copper ports and then 2 gigabit SFP ports.
And those SSP ports give you options. They let you run fiber. So if this unit is sitting in an amp closet on the other side of the stadium, you're not worrying about the 100-meter limit of Cat6 cable.
Plus, you've got built-in redundancy right there.
Absolutely. In any kind of live event, you can't have the show stop because someone tripped over a cable. You run primary and secondary networks seamlessly.
And the latency is down to 0.250 milliseconds. It's virtually instant.
Basically, yeah.
Yeah.
And then you have to control all of this, which is where the QSYS ecosystem comes in.
Right. It shows up as a native QSYS extension. It's all just drag and drop integration.
It completely decouples the physical hardware from the control. You're not walking over to the rack to flip a phantom power switch.
You're doing it from the software, or it's all automated.
Exactly. The
Yeah.
hardware just becomes this transparent on-ramp to the network. The network does all the heavy lifting.
So it really solves that headache of bridging the analog and digital worlds. You get the quality of heavy iron with the flexibility of IT management.
That's the whole shift we're seeing, away from heavy copper snakes and toward these dense smart edge devices.
It's a really compelling package, but here's a thought to leave you with.
Okay.
We're seeing 16 channels of studio-grade audio fitting into this tiny 1-inch high slice of a rack. It makes you wonder, are we reaching the physical limit of hardware density before the I/O itself just starts to disappear into the device entirely?
That's a really good question.
Just something to mull over. Thanks for joining us on this deep dive.